Hello everyone.
My name is Christine Janelle F. Omega.
My name is Maria Francesca M. Rolona, and you are now watching The Science Factory. When we say cycle, it is a series of events that are regularly repeated in the same order. The gas cycle is one in which the working fluid is a gas. Deal with power generation systems in which the working fluid stays a gas throughout the cycle. In other words, there is no change in phase. Some example of the engines that operate in gas cycle are compression ignition or diesel, spark ignition or gasoline, and conventional gas turbine engines, which are generally referred to as internal combustion engines or IC engines.
Did you know, in relation to thermodynamics, calculating the gas cycle has different kind of processes that we can consider? Actually, these are isothermal, isobaric, isochoric, and adiabatic that have reversible and irreversible processes. So, the formulas that you see on the screen are what we're going to utilize in order to solve what is in need under the gas cycles. So, to further elaborate this, let's hop onto the problem-solving part of this video. For step 1, what we're going to use is the formula of ideal gas law, which is PV is equals to nRT. So, through substitution method, that would be 7x is equals to 50 times R is 0.08206 over 1 times the temperature, which is 400 Kelvin. So that would be 7x is equals to 1641 and 0.2. So our V1 is 234.46. Since we have our second volume, we can now find our P2 or the second pressure. So what we're going to use here is the combined gas law, which is P1 V1 T2 is equals to P2 V2 T1. Okay, since again the volume is constant, we can now cancel the V1 and V2. We can use the P1 T2 is equals to P2 T1. So through substitution method, 7 atmospheric pressure times 700 Kelvin is equals to X, which is the second pressure, times 400 Kelvin. So that would be 4,900 is equals to 400X. So divide both sides by 400, so that would be X is equals to 12.25, or our second pressure, or P2. In order to find V3, our third volume, we will be using V2 T3 is equals to V3 T2. So through substitution method, V2 is 234.46 times our temperature, 800 Kelvin, is equals to X times 700 Kelvin. So through solving, what we find is 187,568 is equals to 700x. So what we have is x is equals to 267.95, or that is our third V3. So since the temperature is constant, we can already cancel that on the formula. What we're going to use now is P3 V3 is equals to P4 V4. So for substitution method, 12.25 times 267.95 is equals to 7.65x. So what we have is 3,282 and 39 is equals to 7.65x. So cancels, divide 7.65 on both sides. So that would be x is equals to 429 and 0.6, which is our fourth volume, or our last volume for us to solve this problem. Now you can check the table for your reference, and now we can go ahead and do the next step. So for isochoric process, the formula is theta U is equals to NCV dt, wherein theta U, or the change in internal energy, is equals to mole times heat capacity as constant volume, and also the dt. Alright, for on substitution method, that would be 50 times 7 over 2 times 8.314 over 1. So the 7 over 2, that is the constant volume for polyatomic gas. Since based on the problem, it is stated that we have a polyatomic gas. Then R is 8.314 over 1. So what we have in here is theta U is equals to 436,485. Okay, so substitution, theta H is equals to 50 times 9 over 2 times 8.314 over 1 times the dt, 700 minus 400. So our theta H is 561,195. So for isochoric process, Q, or sensible heat, is equals to theta U. Thus, Q is equal to 436,485. And then we have work, W is equals to 0. Now we can write W is equals to 0. Now for theta S, substitute 50 times 7 over 2, which is the constant volume, times 8.314 over 1, ln 700, which is our T2, over T1, which is 400. Now we have the theta S is equal to 814.21. Okay, for our next step, what we're going to use is NCV dt. So substitute 50 times 7 over 2 times 8.314 over 1 times the dt, 800 minus 700. So for theta U, we have 145,495. So for theta H, we have NCT dt, which is 50 times 9 over 2 times 8.314 over 1 times 800 minus 700. So that would be theta H is equals to 166,280. So for our sensible heat, based on the formulas, for isobaric, Q is equals to theta H. Okay, thus Q is also equals to 166,280. Now, for us to find the work according to the formula for isobaric, that would be W is equals to negative N R dt. So to substitute, that would be negative times 50, which is our moles, times R, 8.314 over 1, times dt, 800 minus 700. So we have a work of negative 41,570. Now, after getting the data for work, we can now jump to theta S, or the change in entropy. The formula for that is NCP ln T2 over T1. So theta S is equals to 50 times 9 over 2, and R is 8.314 over 1, ln of 800 over 700. Okay, to calculate that, theta S is equals to 249.79 joules per Kelvin. Last step, according to the problem, the one that is constant is the temperature. So what we're going to utilize is the isothermal process. To move forward to find the work, which has the formula of W is equals to negative nRT ln of V2 over V1. So to substitute that, W is equals to negative 50 times 8.314 over 1 times 800, which is the temperature, ln of 429.06 over 267.95, which is our volume. Okay, to calculate that, we have W is equals to 156,568.04. We can now go ahead and find the theta S, which has a formula of NR and ln of P1 over P2. Now, theta S is equals to 50 times 8.314 over 1 ln of 12.25 over 7.65, which is theta S is equals to 195.72. So based on the table, the total of theta U of the three process that we have used is 581,980. For theta H, that would be 727,475. For Q, 759,333.04. For W, that would be negative 198,138.04. And lastly, theta S is equals to 1,259.72.
The given is 20 moles diatomic gas. The required in the first problem is the total of delta U, delta H, Q, W, and delta S. The given are P1 is equals to 480 m, V1 is unknown, T1 is equals to 300 K, P2 is unknown, V2 is unknown, T2 is equals to 500 K, P3 is unknown, V3 is unknown, T3 is equals to 900 K, P4 is equals to 6.23 ATM, V4 is unknown, T4 is equals to 900 K. To find the V1, let us all use the formula PV is equals to nRT. 4 times X is equals to 20 times 0.08206 times 300, and it is equal to 123.09 liter, and that is our V1. To find the P2, let us all use the formula P1 times T2 is equals to P2 times T1, and then substitute all the given. 4 times 500 is equals to X times 300, and it is equal to 6.67 ATM. For us to find the V3, let us use the formula V2 times T3 is equals to V3 times T2 and substitute all the given. 123.09 times 900 is equals to X times 500, and it is equal to 221.56 liter, and that is our V3. To find the V4, let us use the formula P3 times V3 is equals to P4 times V4. And let us substitute all the given. 6.67 times 2.21.56 is equals to 6.23 times X. And it is equal to 237.21 liters. Now, we are done computing all the pressure, all the volume, and all the temperature. And if you're done computing all of those, you can now start computing the delta U, the delta H, Q, W, and the delta S. So the first step is finding the delta U. So the formula in delta U is equals to NC VDT. And then substitute all the given. 20 mole times 5 halves times 8.3145 joules per mole K times 500 minus 300 K. And it is equal to 83140 joules. The formula in delta H is equals to NCPDT. And then substitute all the given. 20 mole times 7 halves times 8.314 J per mole K times 500 minus 300 K. And it is equal to 116396 joules. Delta U is equals to Q. Now, we have delta U, so our Q is equal to 83140 joules. W is equals to 0. The formula in delta S is equals to NCVLN times 2T over T1. Substitute all the given. 20 mole times 5 halves times 8.314 J per mole K ln times 500 K over 300 K. And it is equal to 212.35 J per K. Delta U is equals to NCVDT, and then substitute all the given. 20 mole times 5 halves times 8.314 J per mole K times 900 minus 500 K, and it is equal to 166280 joules. Delta H is equals to NCPDT, and let's substitute all the given. Delta H is equals to NCPDT. and then substitute all the given. 20 mole times 7 halves times 8.314 J per mole K times 900 minus 500 K, and it is equals to 232792 joules. Delta H is equals to Q, but now we have delta H, so Q is equals to 232792 joules. The formula of W in isobaric is negative NRDT, and now let us all substitute the given. Negative 20 moles times 8.314 joules per mole K times 900 minus 500 K, and it equals to negative 66512 joules. Delta S is equals to NCP ln times T2 over T1, and then substitute 20 mole times 7 halves times 8.314 J per mole K times ln 900 K over 500 K, and it equals to 342.08 joules per Kelvin. The last step is isothermal. So isothermal is a process in which a system changes, whether it be the pressure, volume, or the temperature. In isothermal, the delta U and delta H is equals to 0, while the W is same as the formula, negative nRT ln times V2 over V1. So substitute negative 20 mole times 8.314 joules per mole K times 900 K times ln 273.21 liters over 221.56 L, and it is equals to negative 10214.11 joules. And now we are done in the process of finding the delta U, delta H, Q, W, and delta S of isobaric, and isothermal. The total in delta U is equals to 249420, the total in delta H is 349188, the total in Q is equals to 251320.11, and the total in W is negative 76726.11, and the total in delta S is 565.78. And that was it. How are you guys? As we bring our discussion about the gas cycle to an end, we hope that you have learned something from us. We hope to see you again soon on our next episode. Bye!